One of the most common problems dealing with Pythagorean theorem is, given a right triangle, can you find a missing side length? So I'm going to go ahead and talk you through how to solve a problem like this. And we're going to look at one of the more complicated types when you have x as a missing leg. So we have x as a missing leg here, the other leg length is 15, and then the longest side of our right triangle, which is called the hypotenuse, has a length of 17. Now the Pythagorean theorem states the sum of the two squares of the legs, so we can call the legs A and B, is equal to the hypotenuse squared, which in this case is always the longest side. It's directly across from your right angle, and it's going to be 17. So now that we've identified our A, B, and C based off of this triangle, we can go ahead and substitute those values into a squared plus b squared equals c squared, and we will end up with the equation x squared plus 15 squared is equal to 17 squared. At this point, now that we've plugged in all of the values, we're going to go ahead and solve for x. To do so, we're going to have to follow our order of operations and look at the exponents first. So x squared is going to stay x squared. 15 squared, 15 times 15 is 225, and that will be equal to 17 squared, 17 times 17, which is 289. We are left with the equation x squared plus 225 is equal to 289. To get x squared by itself, we need to undo this adding here. So to undo that, we can go ahead and subtract 225 on both sides of the equation, and in doing so, the 225s will cancel out, and we will be left with x squared is equal to 289 minus 225 gives us 64. The resulting equation is x squared is equal to 64. To undo this square, so to speak, we are going to take the square root of both sides. So the square root of x squared gives us x, and the square root of 64 gives us a positive 8, since we're focusing on a length, so we don't want any negative values, which then tells us that x equals 8, and the missing value for the side length here is 8.